Hello.
Yeah.
Yeah. Now you can see the screen. MvDad.com.
Yes. Now.
Yes, sir.
Visible now.
May I proceed?
Please.
Yes,
MvDad.com is the stable structural solution. Motivators are Sir M. Viswasraya, India's greatest civil engineer, and Dad, my professor P.K. Karamchandani, father. Information is nothing but, in short, I will give you the guidelines, what it contains. M stands for movement, B for shear, D for deflection, A for analysis, and D for design. Again, MvDad. It's online as per IS course 456 and 1893, then Ductile 13920. Accessible from anywhere. Analysis, detailed analysis, coefficient method, fixed length method, 2D, 3D, finite element method for the static loads and for the dynamic loads or horizontal loads, earthquake equivalent static method, dynamic analysis by response spectrum method, again in two parts, complete quadratic method, and SRSS square root of sum of squares method. Generally, softwares provide only analysis or design. We have tried our level best to combine the both so that the end result should be available with the user. And design is most economical with the detailed calculation. We will discuss it further, and we have provided the drawings, steel drawings, schedule drawings. It are very easy to enter. Any layman can enter. Reports in Excel format, graphic format. It is multi-user. Number of users can use it from any place, and we have given them multi-rights. At the site engineer, one can see only the drawings, and the admin, he has the rights to edit and check the calculations. Capital cost is, for students, it's 0. First, we will go through the new project data. We require only 12 data from the user to select from the drop-down boxes. City, state, floor, basement height. Only one data we have to enter, that is bearing capacity of soil. And after that, we need the center line plan as it is shown on the screen, along with the column locations. If not, then very simple format. In Excel format, one can give this tab number, X coordinates, Y coordinates, span in X direction, span in Y direction. Same way for column location, X coordinate and Y coordinate. And beams we generate automatically. Now we will see that. Just we will start with a new project. We'll write the name of demo SGSI. Password SGSI. Repeat password. As we have created the new project, we have saved that password. For earthquake purpose, we need the seismic zone and seismic factor. One has to remember all these data. If there is anything wrong, then full structure will be at the risk. So what we have provided the user, just to select the location. Here we will select the Madhya Pradesh, district Indore, city Indore. For that, seismic zone is 3, seismic factor is 0.16. Next, we have to select the building type, commercial, hotel, office, residential, or school. In our case, we will see residential. According to the building type, the loading factors as per the IS code 456 and 875, slab loads and I loads, they will be selected as per default values. So that's why building type 1 has to select. My unit is feet or meter. We are selecting meter. Number of stories, up to 13 stories we can design. That means up to 40 meters. We will consider here 3 story for demo purpose. We have given the choice to the user to select the floor height. Here we are selecting 3.5 meter from per ground to first floor. And for rest of the floors, we are selecting 3. 1 to 2, 3, 2 to 3, 3 meters, 3 to terrace, 3 meters. As per the building type, all these loads, floor finish, lie load, they are as per the default. Here what we have did, we are giving the option to the user. He can increase the load, but he is not supposed to select less than the IS codes values. Instead of 1.5, one can select 2, 2.5, 3. For this project, we will consider the default IS loads and accordingly we will proceed. Now, for the beam loads, width, wall load, wall availability, if there is a wall type. For external, we are considering 0.23 floor to floor height. For internal, we are considering 0.15 floor to floor height. Pardi, if there is any pardi, floor to floor height, or up to particular level. For parapet, terrace parapet, we will consider 0.1. Now, plinth height, meters above ground level, 0.6, 0.4, 0.7, we are considering 0.6. Foundation below ground level, we are considering 0.75. According to the site condition, one has to select the data and the soil type, soft, rocky, medium, rock, hard. Now only this data one has to enter, nothing else. Otherwise, all the data we have selected from the drop-down boxes. 330 kilonewtons per meter square is the bearing capacity of soil. Now the grade of concrete, M15 to M40. For residential, we will consider M20. Grade of steel, 415 or 500, considering 415. This design is limit state method based on IS 456 and IS code 1893. For foundation, as per working stress method. We will see in the next. Now slab data, click here to upload the star data. We have the 2-3 options. One is the easiest way, like this Excel sheet, which I have shown you, the data, data in the Excel format, which we will upload. Indore. We uploaded the data. Next, we are selecting that data. For the beam also, column also, the same options are available. Now at present we are considering only the slab data from the Excel. Up to here we are using the data as per the site condition. After that, our admin will check the data which they are entered. Are they as per the standard norms? Sometimes what happens, if we enter the wrong values, the results will be funny. If we enter the garbage, we will get the garbage. To check that, we are getting the data from the user only up to here. And after that, what we do, admin will give the rights, it is okay, to the user. And here we are giving the rights to the user, what one can see and what one can omit. We made that active. Now we are giving them the rights. Just we will see, proceed. Blank, totally. Just have a look, select floors. We have selected 3 floors, accordingly, 3 and terrace. First, we will see the data what we have entered project. We entered residential, building type, unit meters, number of stories 3, and floor height 3.5 meters from 0 to 1, then 3 meters for the rest of the floors. Slab loading, terrace, floor, WC, loft. And wall, external wall width, internal wall width for the earthquake for Madhya Pradesh, Indore, seismic zone, and seismic factor. For foundation, plinth height, below ground level, above ground level, and below ground level. Soil type, and bearing capacity of soil. Just to check what the data entered, according to that data, we are proceeding further. If there is anything wrong, one can edit here only. Now we will go to the slab. Just we have entered the data in the Excel format and we got this 6 slabs. It's very easy. Now we will copy slabs on other floors. Copy from first floor, on terrace, again, third floor, copy from first floor, second floor, copy from first floor, we have copied the slabs on all the floors. Just we will check 0, 1, 2, 3, terrace. Next is we will select the column on off column. Now we have to select the column. 2 options, either from the Excel format, one can copy as we did for the slabs, and another option is select the location, click it, and you will get this menu, sub-menu from 0 to 4, from bottom to top. We will save it. Again, from 0 to 4. Six columns. We selected 7, 8, 9. Just we will check whether they are on all floors. At 0 they are 1, 2, 3, yes. Now we are coming to the beam. Again, on. This is the third option. One, data from Excel. Second, you click the data on the screen. Third, auto-generate the beam. We will generate auto beams for all the floors. Within seconds, we have generated all the beams for all the floors. And each and every floor, 14 beams are available. On ground, and first, second, third, and test. Up to here, one has to do enter slab data, beam data, and column data only in the format where it is available. The slab and supports condition, slab loading, slab one-way, two-way, same-way, beam continuous, beam one-way, or beam in simple supported, both continuous. All this is the automatic. I will show you only the demo. See here. All the floors, tabular format, data is there. Now we will see in the graphic format. Here it is. Slab one way. Now end conditions, if we see with the color, simply support other continuous. S1 is simply supported at the B1 end, and the B3 end it is continuous. And S3 both side continuous, S4 both side continuous, S6 B left side continuous, right side simply supported. And S2 and S5 are simply supported. From the screen one can see the end conditions of the slabs. In the same way, for a beam also, you can see. This full project already analyzed and designed, and it is available online. Now, if any one of you or all of you can log in, I will share you the details. Project name is iDemo. Password is SGSI. I am sharing that password with Tiwari sir so that you can share with the students, and online we will discuss the further. Now we have given you the limited rights. Slab you can see, same way beam. B1 is simple supported, continuous. B2 is continuous, other simply supported. Now only this screen is available with the user. And floor menu, plan and elevation menu, model, expand, plus, minus, and arrow, left, right. And these are the results. One menu, all the results available on your screen. Even you can check it on your mobile, laptop, subject to your network availability. Apart from this menu, now this is the sub-menu button. If you click on the slab, you will get the slab functions. If you click on the beam sub-functions, column sub-functions. No need to remember. Now, if you have any issue, you can ask me so that I will clarify that, and after that we will proceed for the solution. Hello, Tiwari sir. Hello, can you hear me?
Yes, sir. Thank you so much, sir. We sincerely appreciate the time you provided for bestowing us with your exceptional knowledge. We are grateful for your valuable advice and experiences. Now, I will request the students to come forward with their queries, please.
Sonalika, wait. Sonalika, wait.
Okay, ma'am.
Sir, Tiwari sir is not present at the meeting.
Okay. Anyone who is conducting it, just if there is any query or any doubt, so that I can clarify here. Otherwise, I will proceed to show the solutions, results. May I proceed further?
Yes, sir.
Okay. We are in the slab. As I already told, S1 is simply supported, other continuous. S3 is both continuous, S4 both continuous, S6 continuous, other simply supported, and one way. SIDL and SILL, they are in the bracket. We can check it. For terrace, the values are different. Now, we will come to the solutions. Just you click on the slab, one will get the steel schedule for the selected floor with full slab details, effective cover, effective depth, slab dimensions, grade of concrete, and quantity of concrete. Steel in Y direction, steel in X direction, number of dia at the center to center, weight of the steel per slab, which we require for the bill of quantities. If you want to see the actual calculations as we do in the college examination, here it is available. We have selected slab number S6, floor number 1, continuous, other simply supported one way. As per IS code, it's fully explained as per the IS code we have followed, and one can go through it because civil engineering is very vast subject. At right time, I am giving you the demo of the software, that what is inside this and how one can use that and get the benefit. As per the IS code, coordinates 0.6, 0.45. Accordingly, we have selected the depth of beam or depth of slab, loading SIDLL, SILL, shear coefficient, head load, lie load. We got the data for slab and column. In our software, automatically modeling, designing, and analysis is carried out, which is very easy. Anyone can use it, and one can see the results whether they are as per the IS code or not. Otherwise, in all other softwares, just we will get the results in tabular format, and we don't know whether the values are correct or not. But in this, we have provided you the full detail alternating bending moment at top, at center, at left support and right support. Our beams are very much economical. Reason is that maximum of softwares are using bending moment at the center of the column for the beam designing. But whereas we are using the bending moment, yes. Any problem? May I continue?
Yes, sir. Please.
We are using the bending moment at the face of the column. By this, the section becomes the economical. And the top bars, all these are calculated, area of steel calculated. If one has the other options to use other type of bars as per the site conditions, we have provided them the area required as per the loading conditions. One can design the steel as per their site conditions. But what we did, by providing this dia, we have given the economical size for 480, whichever combination is economical, near to 480, that we are providing, and hence it is economical. Same way, now we can see the calculation. Here it is. Left support, simple, right support, simple. The beam which we have selected, it's simple supported. As per the end movement conditions, we have calculated the end movement and end shear. The load from the walls, self load, then the load from the slab, again in two form, dead load and live load. Then summation of these two, A plus B, and movement distribution method. That is, for slab we have used 2D analysis. For beams we have used a 3D analysis to make it economical. This is simply supported, so the end movements are simple, 0.5, 0.5. Accordingly, the load is distributed and values are calculated. Here we got the shear force and bending moment diagram. Oh, sorry, shear force and bending moment. We will see the diagram also. And this is a finite element method which calculates distance wise, and accordingly we can draw the shear force and bending moment diagram. That is cumbersome at this stage. One has to go through it, and it is available on your mobile. Here it is, shear force and bending moment. We got the values. The face, one can click it and see. For dead loads, for live load, separate values, and accordingly the steel is designed. The beam is I beam, T beam, L beam. For flange beam, as per the IS code, that formula is used. Calculation, steel is saved, singly reinforced beam, main steel calculation, top steel, compressor steel, and total loading. Again, we have checked this as per the 13920 IS code. There are no number of clauses one has to go with, so the structure should be ductile. All the conditions we have checked. If it fails, and the section is revised, and reiteration process will go on. I will show you that also. It's very simple. And shear check, deflection check, development length, effective depth. This is the IS code 13920. All these conditions 6.12 to 6.35. We have checked. If it is okay, then we have finalized that section or element. Quantity, cement quantity, weight of steel, stirrups steel, in this tabular format, which I have already shown you for the full floor. Now the loads from the beam to the particular column, that is shear value, that we will see further. Now we have seen that simply supported one. Now we will see this one, B4 and B5. Yes? Yeah. Now we are, sorry, wait. He has selected slab. Yes, now it is. Even all of you can take it on your mobile or laptop. The same project is available with you also. And we have selected this beam. Beam number B4 and B5. Self-weight, wall load, load from the slabs, total continuous, other simply supported, then B5 to calculate their end moments. As per the moment distribution method, we have calculated here. As per the 3D analysis, column is there. For 2D analysis, only beams supports are there. The same calculations we can see in the graphic format also. Here we got the bending moment and shear force. And finite element method for graphic purpose. We are coming to the design now. This is the analysis. Now one can see at the center of the column, ends of bending moment is 91.63. But at the face of the column, it is 77.69. So this difference is economics. According to 77.69, we have designed the steel and provided at the support. Again, it is T-beam, line section. According to that calculation, B4 is simple and continuous. Hill design. We have selected the section. We assume the section is 385, 500, 400, and effective depth. That we finalize. Depth is 400. Effective depth is 360. T-beam. And according to that, we have provided the steel. Number of conditions as per the 13920. All these are implemented, and accordingly this element is designed. Top steel, center steel, bottom steel, and shear check, deflection check. If the section is set, then it will be analyzed. And slab weight, quantity, steel, these are the final results. What you have seen in the tabular format, now we will see in the shear force and bending moment diagram. There it is. V4 and V5 values are there. .43 at the face of the column, which I have shown you. For each and every floor, you will get the values. And accordingly, the section is designed. This is bending moment deadlock, max minimum, live load, shear force. Shear force deadlock, shear force live load, and shear force maximum. This is nothing but ECG. from graphic only one can see the values, and just you click that point, you will get the value. And the Y section, see that also. Shear force, bending moment. There is a point load, and accordingly, movements are distributed. We try to provide the basic requirement in graphic, in tabular, and detailed calculations. Now we'll come back to the plan. Now we'll see how the load is transferred. Oh, sorry. Now still. Sorry. Let me jump there. Number of bars at top, bottom, at left support, at section BB, at section CC. All the values are there. One can check it, verify it. Now we will see how the load is transferred from slab to beam. On this beam, as it is simply supported, then load from S3 slab and load from S4 is transferred. And for this B5, only the regular load. Okay. Yes. But just you got the idea how the load is transferred from the slab to the beam and from beam to the column. So next is again print out. Same menu. Now we are coming to the column. Full floor, steel schedule, column height, clear effective height, effective cover, grade of concrete, grade of steel, section size, main steel, steel stirrups, area of steel, quantity, weight of main steel, weight of secondary steel, total. Again, the same detailed calculations. How the load is transferred from beam to column, then movement from beam to column. So to decide the axial load, biaxial, uniaxial, and accordingly the section is designed. So the vast subject, you go through it, and your teaching staff are the better guide to guide you. We have assumed the section, we get checked it. If it fails, by reiteration, it goes on revising the size. If we have provided the steel and 75% assumed as per the IS code, sometimes what happens if the load is less, but we have to follow as per the IS code to provide the minimum steel. So we had checked on that by section size, steel should not be provided. But as per the IS conditions, steel should be provided. Again, as per IS code 13920 also, the clauses which we had checked, and accordingly the section is designed. Load cases, find out the movement, and according to the movement, we are skipping this designing section, which is available. And again, the total result of the particular column. Now let's see the third step. Number of bars, stirrup, 16 mm dia, bars 4 on both the side. The stirrup is 8 mm at the 260 mm center to center. We have provided you slab, beam, column, results in tabular format, in Excel format, and graphic format, and drawings. Same way for the footing, steel design for the full footing, concrete grade, steel grade, common menu for each and every element. The data will be displayed. Detailed calculation as per the working stress method, working method as per the IS code. We have designed the section. Just I want to show you how the section is decided by the software. We start with the lower size and we check it whether section is capable to carry the load, capable to resist the shear and bending moment. If it fails, then we increase the size. In this case, we will see the section size we have considered is 430 mm. See the loop. Else, goes on increasing the size. Now, section size from 430 to 100. 530 it is increased 100 mm. Again, we will check it whether the section is safe or not. Again, failed. Again, failed. Now, loop ends. That means this 730 section which we have selected, now it is set. Again, we take the development length. If development length is not as per the required, then increase the development length. Only difference is 12 mm. So it's better increase the development length as per the requirement. The same for y-axis calculation is done. Our motto is that the section should be economical as well as it should be safe to carry the load. Not only static, but dynamic also. That means for earthquake analysis also. Up to here, we have discussed the footing, slab, beams, columns. Now all the results just available on this menu. You select that, you will get the results on that screen only. The plan format, beam dimension, in plan or in elevation. Now, beam is still in XX direction. For B1 beam, top bars, bottom bars. For B3, for B4. For beam in YY direction, for B9 values, for B11, for B30. That is on the plan only one can see the data. Same way for column steel. You change the floor, values will be changed. Now we are coming to the main earthquake. Till now we have discussed about the static loads, that means dead load and live load. Here we are coming for the earthquake loads or horizontal loads or seismic loads. Whatever you are comfortable, you can say. And then you will see the eccentricity, center of mass and center of rigidity. Just to check the value, center of mass is 4.72 and 6. From X direction 4.72 and Y direction it's 6. And center of rigidity, it varies. It varies with the section size, column size, beam size, stiffness. But center of mass remains the same because the slab load, slab values are the same. Same way, center of gravity. Now we have shown it in the graphic format. Torsion. We will discuss about this. We will show you the detailed calculation also. Just have a look at the graphic format. How now the drift. This is nothing but the displacement as per the horizontal loads. For a stable section, it should be less than 0.04. We will discuss further. And one can see this zoom. How the structure will depict in the at the time of earthquake load. Same way for the Y section. Now we are coming to torsion shear. In X direction, torsion shear in Y direction. Now again, the calculation. To understand how these values arise, On runtime, full calculation is yes. We got the full calculation for the project hire demo. As per IS 1893 Part 1, Clause 7.4, reduced live loads are used for the analysis. 0 on terrace and 50% on other floors of if SIL is less than 3. The slab load, beam loads, beam weight, wall weight, column load, summary of floor wise, and total. Weight of slab, weight of beam, weight of wall, column, total floor weight, total floor height. Weight of the building we have found, height of the building we have got, of actual length and width of the building are in X direction and Y direction. X direction is 9 meters, and Y direction it is 12 meters. Accordingly, we have to calculate the earthquake loads in XX direction. In starting, we have selected city Indore. According to that zone and safety factor, we got by default. Earthquake loads in X direction, as per the formula, natural period of vibration and frame response factor, type of building residential, R and I. That is calculated in as per the IS code only, zone, in that formula, and we got the seismic base shear. Horizontal shear in the X direction. That is VB 250.92. 50.8. M in earthquake load in Y direction. We got that. That is in the tabular format. In XX direction and Y direction. The values which we have seen in the graphic form. Calculation to determine center of mass of the building. That is calculated. Center of mass 4.72, which I have shown you in X direction, and Y direction it is 6 for all the floors. Then static eccentricity in the X direction and X and Y direction. Again, as per the IS code, design eccentricity is given by this formula, class 7.9.2, and its values which we have shown you the floor wise, center of mass and center of rigidity. Here we have calculated center of rigidity or center of stiffness, whatever you can call. Again, that values are in the tabular format. Both the values, center of mass and center of rigidity, is in the common. Up to here, it is the static analysis as per the IS code. Now, as per the latest IS code, all the structures should be tagged as per the response spectrum method. Dynamic analysis. This is nothing but MATLAB software which we have developed from the scratch. And for each and every project, we are calculating the stiffness and natural time period. It's very simple. This is mass matrix, then stiffness, then Eigen equation. According to Eigen equation, matrices. We calculated that. Now we are doing the reiteration till we get the result. Here we got the result. Natural frequency for this. To find out the multi-degree of freedom. Now, we just skip that. Yes. We got the natural time period in XX direction. These are the values in seconds. This is nothing but the multi-degree of freedom. That is, up to 5 mode, we got the values. And according to that, we have to find out the modal mass and percentage of total weight and modal participation factor. Again, these are as per the formulas, nothing but we have evaluated and calculated the values. And we are giving the detailed calculations so one can understand how the results are arrived. Now, again, IAS code says if number of modes up to 90% of the total value is considered for further evaluation. That means instead of 5 modes, if the summation of these modes, 51.81 plus 58%, it's more than 90%. That means only these 2 modes should be considered for the further evaluation. So, as per these 2 modes, we are calculated the sum of square root of sum of squares. That formula. And according to that, we have calculated the lateral load. Here we got the. Now, again, that is another method, SRSS method, and this is CQC method. Lambda, that formula we calculated. Again, matrices, MATLAB software, one can say. Detailed calculation, and shear forces as per the CQC method. First, we got the as per the equivalent static method, then CQC method, then SRSS method. If we check the values, the static method values are higher compared to the CQC and SRSS. Again, IS code says you have to increase the value to the level of the equivalent static method. So, as per this formula, 1.94 times, we are increasing the values of the dynamic values. If you see 49.27 multiplied by 1.94, these values governs the stability of the structure. These are the final and tabular format it is there. Lateral force and shear force, which we saw in the diagram by checking the same calculations. Now, eccentricity in x direction. Accidental dynamic eccentricity. To determine the static eccentricity and design eccentricity of the building. And from there we got the torsional shear. Again, this is a vast subject. One has to update his knowledge, and it is available. You can check the values also. It will guide you to understand the subject. Torsional shear and total shear at each column. Torsional shear, results of direct in the table. Column number, node number, maximum direct shear value. From here, seismic force, total deflection and drift. To check the stability of the structure, one has to satisfy the drift value. The drift value is what? We will see. Drift of column, stiffness of column, load provide, drift of column where load to provide, modulus of elasticity. As per clause, sir, the drift should not exceed 0.004 H. That we have calculated, and we have to see that drift should be less than 0.004 H. Calculation again. Column stiffness, column drift, and frame column, floor column. Here we got the drift and displacement in X direction. Story 4, lateral force is 96, floor drift is 0.15, floor displacement is 0.26. 3 values are there. We got the dynamic lateral force and dynamic shear force, which we already calculated. Now we have to see from these two beds the stability of the sway or not sway. Here we have provided you the two values, one from the static values and one from the dynamic values. Just for the reference purpose, one can see the static values are okay or dynamic values. But we have to follow the dynamic values as per the IS code, which are this calculation of stability indices as per the seismic weight. Here what we got? 0.000667. That means it is less than 0.004. Hence it is non-sway. The stable structure is stable. If the structure is sway, then we have two options. Either we have to change the element sections, or we have to go through the 25 load combinations. In our software, we have tried our level best so that section should be economical as well as it should be stable. Hence, we have calculated, checked, the section is non-sway, that whatever the sections elements we have designed, they are okay in the seismic loads also. The same way, calculation for the y direction is a totally purely repeat. You can go through it. You will see what is the condition of that. Here we got the natural time period, 5 modes. Again, in 2 modes, 73 point and 53 point. More than 90%. For further evaluation, we are considering mode 1 and mode 2. HRSS method, values are there, and by CQCC method. Now, in y direction, equivalent static method, CQC method, and SRSS method. As per the y direction. Okay. For x direction, we have enhanced 1.94, and for y direction, we got 1.65. See the length, structure, and accordingly, one can judge how these values arise. dynamic analysis, response spectrum method, and y-bar. These are the final values for the y-bar direction. Same for to check the stability in the y direction, we have to calculate torsion. And we got the drift values, which we have checked it. In both the cases, it's non-sway. That means structure is safe. If it fails, then we have to go. Can you hear me? Huh? Yes. Section is the floor is sway as per the 25 load conditions. We have to provide the additional steel to make it stable. Per case, the section is set. Now we have covered all the points. Slab we covered, shear force, and walls we have to discuss, 3 walls. There's no terrace, no internal wall. And floor 1, internal wall first. You can see that this type of wall is available. You have seen the project, slab, beams, columns, walls, shear force diagram, column.
Excuse me, sir.
earthquake. That is the
Sorry
last.
to interrupt you, sir.
Can you hear me?
Yes, sir. Sir, your voice is not clear.
Now is it clear?
No, sir.
Now? Now is it clear?
Yes, sir, better.
Okay. Now it's the last point. Material. We can say bill of quantity. We will see the steel. For the full project, bill of quantities will be calculated. Yes. Steel grade. Project name. Slab steel. Beam steel. Column steel. Footing steel. Again in floor wise. Dia wise. Main steel. Secondary steel. Secondary steel dia. Main steel dia. Grade of steel. For all this section, 8813 kg. Slab, beam, column, footing, total steel. Now, steel summary. Floor wise, footing, slab, beam, column. For first floor, slab, beam, column. That is, at the time of execution, contractor or builder can go through it and accordingly he can place the order. Grade wise, dia wise, and at the we got this 8813 kg, same here 8812.2. One can export in the Excel format. Same way, cement. Slab wise, beam wise, column wise, floor wise. Grade wise, 10, 15, 20, 25, 30. For this project, we have selected only M20, but user has the option for any element, for any section, he can select the grid. In quantity in cubic meters as well as in the bags. Again, you can export in Excel. But till now we have covered all the elements: slab, beam, column, footing, and earthquake, static, dynamic, material. We have tried our level best to provide the maximum result by minimum efforts. Now you can go through it if you have any queries, doubts, and here other question. Yes, ma'am. Miss Sonalika, from my side, yes, I covered all the issues. If you have any doubt, you can ask me.
Thank you so much, sir. We sincerely appreciate the time you have provided us for bestowing us with your exceptional knowledge. We are truly grateful for your valuable advice and feel gratified for your efforts to furnish our cognition. Now, we profoundly know as asking questions is the best way to acquire great knowledge. I would request all the students to come forward with their queries. You all may mention your respective questions in the chat box.
Ma'am, just I want to know, have you got the project name and password? Hello. Yes, anyone? एकदम ये कट गया है इसको देखा
So you're not audible. Can you please leave the meeting and join once again?
Okay. Yes. इधर को फिर से connect करता हूँ। Audible नहीं होता। इधर। Now can you hear me? Hello. Am I audible?
Sir, there is some noise in the background.
Okay, let me check. Now is it clear?
Sir, I guess if you remove the earphones, you'll still be audible to us. You can disconnect it from the laptop. Maybe that is causing the disturbance.
Maybe. Hello, am I audible now?
Yes, sir.
Yeah. Have you got the project name and password details?
Sir, I'll share on the chat box.
Mr. Bharat wants to ask something.
Good afternoon, sir. Bharat
Yeah.
Bhavar here.
Yeah,
First of all, thank you very much for such a useful presentation. I'm having some questions, sir.
Yeah.
First of all, the footing has been designed using the working stress method.
Pardon?
The footing has been
Yes.
designed using working stress method.
Right?
So why we are not using limit state here?
No, but IS code says that you can design footing as per the working stress method only. For others, it should be limit state method. Just to verify.
Okay, sir.
Yeah,
And as you said, for the economy, we are taking the moments as at the face of column, not at the center of column.
right. For the beam design.
So yes, sir. So, but for just we seen in the example that the moment at the center of column was around, and at the face it was 75.
Right.
So what about the strength of joint there? Because at the joint there will be the moment of 92, and but we are not designing for that moment.
So, if you check it, when the beam is merged with the column, then there is no need to design the section as per the center movement. You can verify from your professors also and IS code also. Even ETAP do the same way. You can verify that also.
Okay, sir. And as in the IS code, we are having the steels of grade 415, 500, 550, and 600.
Yeah, we can go for that. No issue.
In the drop-down box, there was only two grades,
Yeah,
415
yeah.
and 500.
At present, we have provided that facility, but now the steel has come up, 550 and 600. Even the stainless steel is used in the main structures at Bombay. There is a scope to enhance this. Just we have to put the values, and that values which we have to fetch from the database and calculate it. That is not a big deal. We can do that at any time. We can upgrade them.
And my another question is this software can take care of only solid slab, or it can take care of voided slab, PT slabs, and folded, flat slabs
No.
also?
No, generally what this is, you can say it's a nano car. It's not a Mercedes. It is Mercedes, but this software is nano car. For tier 2 cities and tier 3 cities, where the building is up to the 3 stories, 5 stories, 7 stories, yeah, maximum up to 13 stories. That is up to 40 meters. This software is very good for them because they don't have so much infrastructure or software, hardware. They have to use number of amount is too much. And for our software, just they have to enter the data. We will provide them the solutions. It's just like Ola car, Ola taxi. You just hire the software for that particular project and get the result. That's all. No need to buy the software.
Okay, sir. And another thing is that we are just inputting our need, and the software is deciding the section by itself.
Yes.
And but if we want to play with the dimensions, I am having restrictions with.
Yes, it is there. You can select the section whichever you want, and according to that section, that analysis and design will be checked.
Thank you, sir.
Yeah.
So, reflecting on the question asked by Ms. Neelam Shukla, what is the difference between SAT Pro and MvDad software?
Can you repeat the question?
Yes, sir. This question is asked by Ms. Neelam Shukla. What is the difference between SAT Pro and MvDad software?
State Pro and MvDad. You want to compare that?
Yes, sir.
Yeah, you can compare it and satisfy yourself. No issue. You can do the project on that State Pro and give the data, upload the data on our MvDad. We will give you the result. You can verify. We will be more happy. Yes, Ms. Sonali.
I would request the students to come forward with more queries if they have any at the moment.
No issue. At any time they can approach me on WhatsApp or email. I will be there to help them.
I would like to thank everyone for showing such great enthusiasm. Moving forward, I would like to install your attention towards our organizing team, an initiative of the Civil Engineering and Applied Mechanics Department. Club Stimulus. I request Finance, Treasurer and Executive of Public Relations of Club Stimulus, Ms. Neelam Shukla, to do the honors. Ma'am, please.
Thanks, Sonalika. Good afternoon, everyone. Stimulus is an initiative taken jointly by the Civil Engineering and Applied Mathematics Department at SGSITS Indore, along with our professional alumni, to nurture and untap the hidden potential of every talented civil engineering student. Our third club is a vital segment of Stimulus CEAMD, which will train students in software to help them to build their dream career. We are grateful to announce that we have successfully completed various batches of AutoCAD, and we are soon going to launch fifth batch of AutoCAD. And in parallel to AutoCAD training, CAD Pro training is under progress, and in coming days, we will start CAD Ready and other software also. Under stimulus training program, the learner and teacher are from our college itself. I'm extremely happy to inform that we have trained across hundreds of students at a very minimum cost. Stimulus assures that each and every learner gets authentic, accurate, and adequate knowledge at the end of training program. Thank you.
Thank you, ma'am. Now, heading towards the closure of the session, I would like to invite President of Club Stimulus and student of final year of Civil Engineering and Applied Mechanics Department, Ms. Harshita Nath, to convey vote of thanks and express sincere gratitude. Ma'am, please.
Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. Respected HOD, Dr. H.K. Meyer, sir, respected and most distinguished speaker of the day, Mr. B.P. Karamchandani, sir, honorable professors, and my dear friends. It seems to be a great honor to propose the vote of thanks to all those who have helped us in making this seminar a very resounding success. First of all, I'd like to thank you, our eminent speaker, Mr. B.P. Karamchandani, sir, for this excellent presentation
and making this webinar meaningful and interesting. I'd like to express our deep gratitude to our respected HOD, Dr. H.K. Meyer sir, for his guidance and moral support, and all the professors for blessing us with their presence. I would also like to thank our mentor, Assistant Professor Engineer Vivek Tiwari sir, for his motivation. We have been fortunate enough to be backed by volunteers of Team Stimulus who have participated overwhelmingly, making this event a success. Finally, I thank the wonderful audience for being such keen listeners. Once again, I would thank you for your cordial cooperation. And sir, I would also like to inform you that this session is being streamed live on YouTube. We provide you the link, so if there is any queries, they can contact you there also. And we also look forward to teaching this software at our CAD club at the college.
Thank you, ma'am. Please convey my thanks to Professor Khare and HOD, Professor Dr. H.R. Meyer sir, and Mr. Vivek Tiwari. Thank you to Ms. Harshita, you, Ms. Sunalika, and all the participants for hearing me patiently. Thank you.
Thank you, sir. We are greatly obliged by the knowledge you have shared with us today, and we are looking forward to scaling MvDad as well.
Thank you. Thank you, ma'am.
And yes, endings are beginnings, and beginnings are ours to turn into something really good. Now that we've all got to venture new things and learn invaluable skills under Sir's guidance, I hope that we students continue to flourish under the guidance of our respectable professors even further. Thank you everyone for your gracious presence today. You all may leave now.
Thank you. Thank you.